Hello.
Hello, how are you?
Good. How are you?
Thank you. Eric, can you hear me?
I can hear you
Yes,
just fine. Yep.
What about you? Are you good?
I can hear you. Eric, can you hear them?
yes,
Okay,
I can hear everyone.
Perfect.
okay, perfect. I joined online and my friends are in our workshop, as you can see, and Ahmet Şevket is also joining online. Um, Firstly, we would like to introduce ourselves. We already have met with Eric, but it's our first meeting with Christopher. Actually, we are so excited. And let me start with me. My name is Ömer Faruk. Um, my fifth years in our team, and we will join the competition for second time. And today we will introduce our rocket, which is named Istanbul. That's me. Let my friends introduce themselves. Nurullah, you can start.
I am Nurullah Vedir. I am aerospace engineer.
I am Mohammed Kam. My department is Electronic and Communication Engineering.
My name is Mohammed Isa Ağacı, and my major is Artificial Intelligence Engineering.
Hello, my name is Ali Reza. I am in the department of Electronic Communication Engineering.
I am Abdullah Tavakiras. I am studying mechanical engineering.
All right, Bumin, can you introduce yourself?
Yeah, sure. Do my voice is clear right now? I mean, can you hear me clearly or visually?
Yeah, we can hear you.
Yeah, okay. So, hold on a second, Christopher. Hello, Christopher. Hello, Eric. It's Buminhan Varlı. I'm a kind of CFD engineer at the same time, and I'm responsible for the designing rockets. And in this team, I'm responsible for the main aerodynamics part. And at the same time, I'm responsible for generally speaking, just observing my team and the whole technical details. So it's good to see your name. I couldn't your face, or I mean, your camera is not on, but it's okay. I can.
All right. Ahmet Şevket, can you speak or?
Yes, I can speak, but my camera is not working. So hello everyone, my name is Ahmet Şevket. In this team, I am responsible for production usually, and I am mechanical engineering normally.
Okay, thank you. Christopher, again, we are so excited to meet with you. Kindly, can we request you to introduce yourself?
Yeah. So my name's Chris Nilsson. I'm an aerospace engineer here over in the States. I've been working with college teams for quite some time now. I do everything from liquids, solids, hybrids, monoprop. I do it all, and kind of a trade of all. So yeah, nice to meet you all finally. And I know it's pretty late where you guys are at, so we'll make it short and sweet so you guys can get to bed if you want. So
Cool. Okay. Eric, thanks for your participating. And can you introduce yourself as well?
Certainly. So, I participated in the Spaceport America Cup with my university. That's the Utah State University back in 2018. Unfortunately, finances as well as university issues prevented us from participating during the rest of my time in university. I started as a volunteer for Spaceports for last year's competition. I joined pretty late. This is my first full year as a spaceport volunteer. I was a member of my university's rocketry team for 5 years, of which 3 was spent as the unofficial club president. My last year, I was the official elected president. We completed a number of rocketry projects. I think the one I'm most proud of was we launched a 2-stage rocket, about the same size as one of the rockets behind you, but it was a lot narrower to 50,000 feet.
Wow.
We didn't recover the booster. The recovery electronics failed to deploy, but we did recover the sustainer, which was nice because that was the more valuable part. I completed my level 3 certification in 2019 out of the Salt Flats in Utah. It's an amazing launch site. Unfortunately, no one can ever fly rockets there again, at least not at high altitudes. It's the FAA's fault. They extended the airport.
Eric, may I ask a question to you?
Yes.
As far as I understand that, did you design a multi-stage rocket before? Am I right? I mean, this has
No, that was our first multi-stage rocket.
Yeah.
And only, well, no, we designed a smaller one, but it was about
Okay.
2 or 3 feet long, and it technically never really launched.
So,
But yeah, we went from bed an I impulse to an M in multi-stage
yeah, I got it.
in 2 launches.
I'm asking that because this year I'm also designing multi-stage rocket in Turkey competition, and we will use M and N class for this rocket,
Okay.
and it's very challenging. It's kind of similar thing about the just single stage rocket, and we're about struggling in the separation system actually.
Certainly. If you have additional questions, we can probably talk about it at a later point. We'll want to review your current project.
Okay, thank you.
But thanks. That's all that I have to introduce myself.
Okay, thank you so
Take
much.
it. Yeah, you're welcome.
What's our plan for the meeting? Firstly, I will introduce our team to you, and I will talk about our rocket theoretically. Then we will show the rockets that we product. That's our plan for the meeting. Let me share my screen. All right. Can you see my screen?
Yeah, it's perfect.
Okay. Our team's name is Vefa Aviation, and we are team of Istanbul Technical University, and we were founded in 2018, and we are working on UAV and rockets, and we participated a lot of competition in our country and in international competitions. And we have 2 workshops, which is in one of them is in our dormitory, and the other one is in our university. And we have 4 advisors. One of them is our rector, Mr. İsmail Koyuncu. Past projects, the orange ones, we built them in 2020, and one of them was high altitude rockets. We reached 20,000 feet, and we got a second place in the competition. And we recovered whole parts of the rockets after the launch. And here is our president, Mr. Erdogan. He visited our the stand, and he signed his signature on our rocket. After this meeting, we has chance to reach a lot of sponsorships. and here's another memory. And we built a drone. With this drone, we work with firefighters, and in a competition we got first place with the project. Here's a video. Let me show some of the skills.
Fahiyle röportaj ederek çözüm bulacak. Uğur sizlerle çıkmak. Arkadaşlarımı çıkar.
Here's operation.
Konuşmasına Profesör Tommy Başkanı'nın TÜBİTAK'tan bakalım ne diyecek.
Evet, beklediğimden daha güçlü bir performans açıkçası. Palet hareketli, araç hareketli, yanan bütün noktalar söndürüldü diyebilirim. Köşede bir detay kaldı, onu bekliyorum. Ama kontrol altında pilotun...
We have succeeded this project in 2021. And the next year, we built another rocket, the green one. And we carried kamikaze with this rocket. At apogee point, we release the kamikaze. The wings are foldable. Thanks to foldable wings, we could place the device into the rocket. During the apogee, we release the kamikaze. Then the wings are opened. Were opened. During the recovery the time periods, we had the flight with the kamikaze, and we participated SA Cup 2023 last year, I mean, and in the 10K CAS category we got 4th place last year, and it was our first participating the competition. And it was a really good memory. We had a lot of good memories there. Therefore, this year we want to join again. And let me go. Again, we got 4th place. We had a lot of success so far. Some of them are written in the screen. And this year, hopefully, we will be there. And in same category, 10K cuts. Here is our introducing video.
From Istanbul Technical University in Turkey.
It's a like trailer of the competition 10K CAS 2024. Okay, let me go. And in this section, I want to talk about the rocket which is built this year. We named it as Istanbul. It's a city name which we live in. Here is the pictures of our rockets. Here is the cut view of the rockets, and here's the open rocket view. These are the specifications of our rockets. We have 107 airframe length, 107-inch length, and our diameter is about 5.3 inch. And what else? We have 56.4 ounce mass, lift-off mass, and We will use Aerotech motors, which is M1845. We have bought it, and hopefully we will reach that altitude, almost 10K feet. And during the flight, our static margin is between 1.5 and 3, and we have maximum acceleration, which is 9G. Okay. By the way, if you have any question, please interrupt me. You can ask anytime. You can ask your question anytime. And what's our motor assembly strategy? Here is the cutaway view of our motor site. How we assemble it. Firstly, we place the motor from the bottom of the rocket. Then we push the motor through the inner tube. Then the motor will touch the bolt. After touching, we start to rotate the motor. After rotating, the motor run through the bolt. After motor touch the motor mount, then motor assembly we will finished. After the motor's assembly, after we montage the motor, we fixed the motor into a whole axis. And we analyze our motor mount. We are using 7000 series aluminum, and after our analysis, we had 3.5 reliability coefficient. Nose cone, we have 5 options for geometry. According to our research, we prefer to use von Karman geometry. Then we applied CFD analysis to check whether it is good for our flight or not. Yes, after CFD analysis, analysis results says that von Karman is good for our flight. Therefore, we picked the von Karman geometry. For material of nose cone, we did a trade-off analysis. We compare 4 different options. Then we choose to use carbon fibers based on density, strength, yield strength, cost, and manufacturability. Here is the picture of production. We applied varnish onto the surface to have good aerodynamic property. For airframe, by the way, we produced our airframe in our workshop by ourselves, and we use glass fiber material for airframes because it doesn't cause Faraday cage, and it has a lot of advantages compared to aluminum and carbon fibers. We have 3 different body, avionic bay, the mid bay, and the motor side. Here is the picture of our production. Carbon fiber material for fins. Again, we applied trade-off analysis to choose the material, and here is the picture of our production. Here is the fixture. We are using this tool to montage correctly. And how we montage the fins onto the airframe. We applied epoxy on the whole edge, and we use this strategy, these methods for like 4 or 5 years. and we didn't face any failure with this method. For recovery, we had three options: black powder, the carbon dioxide tubes, anti-spring mechanism, and we choose to use black powder system because it has advantages for volume, cost, and availability. And we applied again trade-off analysis. According to trade-off analysis, we choose black powder system for recovery. And here is the collapse. We have dual deployments. One of them will occur into apogee during the apogee. At apogee time, we will release our payloads, which is drone, and we will open the main chutes of the rockets. Here is the general view of our collapse. For recovery, we calculated needed black powder for deployment which has happened in apogee. We will use 1.6 gram for deployment of shoot. The first shoot. Then we will for the second calculation, we calculated the second deployment, and we will use 2.4 grams for the deployment, which during deployment, which we will open the main chute. And here is the tanks of black powder. We have backup systems. And for first deployment, we will we will have 2 grams for backup system. For the second deployment, we will have 2.6 grams for the backup system. And for chutes, we will use 3 different parachutes. 2 of them for rockets, 1 of them for payloads. And what are their dimensions for drag chutes? Normally we use millimeter. Therefore, because of we use millimeter, the numbers are a bit strange. I needed to convert them from millimeter to inch. This is why the numbers are a bit strange. For drag chutes, we will use chute which has 23.6 diameter. For main chutes, the diameter is about 100 diameter inch. For payloads, for 47. And we use we choose the colors red, black, orange, and green. We choose them to see chutes easily in the sky, and these are the velocities of the fall of the rocket and our payload. All right. Here is our another analysis for recovery site. First, these are the state analysis which is applied for the eyebolt. And for avionics, we are using CAS computers, which are tele-GPS, entocord, telemetrum, and we will have camera into the rockets. And we have 2 number of tele-GPS for tracking, 1 entocord for deployment, 1 telemetrum for deployment and GPS tracking as well, and 1 camera, as I said. Because the computers are using barometric sensors, we will have vent holes onto the airframes. This is the calculations of diameter of vent holes. Okay. For payloads, we will have drone payloads, which is in shape for your CubeSat. why we will place drone payloads. It will collect like air info. I mean weather forecasting. Normally today's balloons are using for meteorological infos, but each time, I mean, balloons after using balloons, they need to they need to buy another new balloons. But if we can use drones for this site, I mean, this is a like cost. I mean, the cost of collecting data from weather is getting low. Therefore, we will use drones which is in for you CubeSat shape. And thanks to this project, we had opportunity to learn a lot of things and practice and have a lot of time in our workshop. And we gain a lot of experiences. And we experience that how we can transform how a dream can be transformed into the product. We experience that. How we do this? Firstly, we create requirements according to requirements of the competition. Then we did a lot of research. Then we did our primary design. Then we analyze our primary design. Then we and we did a lot of calculations. Then we improve our first design. Then we prototype our materials designs. Then we go our laboratories. We did a lot of tests, tensile tests, something like parachute test. Then we reach our detailed design. Then we product our rockets. After whole procedure, we reach our product. And the last thing remaining, painting. We will paint our rocket in shape like how it's seen in the picture. We will come with this rocket as you can see like in the picture. And here is the like basic informations for our rockets. Then if you have any question, you can ask, or we can show our workshop and we can show our rockets. Eke can you, Eke, my friend Eke can our rockets.
Actually, before continue, may I ask a question to Christopher and Eric? Is that okay for you?
Yeah.
So what do you think about our rocket graffiti design, the crocodile design? Do you like it or not?
The paint job, I think it's pretty cool. I think it's pretty sick if you can pull it off.
We are waiting so much right now because at the same time we are curious about it. We just shipped to our friends who is working on the main structure, actually the aerodynamic parts, I mean the rocket itself. So nowadays he's trying to design this crocodile picture in the rocket, and I'm very curious about it.
Yeah, well, it looks pretty cool. Definitely get that up front in the group picture if you
Exactly.
if you get it like that. Overall, the presentation was pretty good. I know the spaceport, admin wants to kind of do you have the rocket with you now, or is it off for paint? I think I missed that. Do you guys have the rocket with you?
Yeah, right now.
Okay.
Okay.
In our workshop, we have rocket right now with friends. But what do you wanna see in details about it?
My friend Eke, can you show the rocket with your camera?
Okay, I will show.
So Christopher, which part of the rocket do you want to focus on? I mean, generally speaking,
Yeah,
or not?
just an overview. They want us to kind of get eyes on the rocket. Okay, so the presentation was fantastic. I have nothing outlying. Did you have anything outlying, Eric, based off the presentation?
Yeah, the only thing I had with the paint scheme is just to make sure to include the team numbers on that.
Mhm.
You guys
They're
made that
typically
news?
put on each of the fins. That's mostly a requirement, one for covering, two for the live streaming team, so that they can tell which rocket is which.
Yeah, I'm looking at your screen here. It looks really nice. And I really mean this. The one of the only concerns I have is are you planning on doing like a carbon fiber layup on the fins, or just leaving the fins as is?
Actually, we're planning about just leave it like that because
Okay.
we have strong epoxy in there. I mean,
Yeah.
the fin tab and our mount of motor.
Yeah.
Yeah,
It's also in there too. Okay. Yeah, if you have
yeah.
it both there
So
and
we
then
have,
on that tube.
and I guess it will be okay for the strength of the fins, I guess.
Nurullah, can you apply a force onto the fins to show how it's strained?
Yeah, I'm not worried about the fins coming off during flight at all. I think those are gonna be fine. Funny enough, I see more rockets break on landing, hitting a rock or something silly, that breaks the tip off. But no, those are gonna be fine for flight. Um,
Actually, this is not only epoxy. There is a powder aerosil. His
Okay.
name is aerosil. It's a mixture with epoxy.
Yep.
It's not just only epoxy.
Cool. Awesome. That looks really nice, guys. Let's see here. I see your motor mount's kind of recessed into the rocket. Is the motor flush with the base of the rocket, or is it gonna sit up a little bit?
And
here's
we have motor dummy, Christopher, because
Nice.
we will reach our motor in United States, but we couldn't check our
Sure.
motor mount design because we will have the motor there. Therefore, we produce a dummy which has
Nice.
same weight and same dimensions. And my friends have it right now. Nurullah, can you show the dummy, the camera, to the camera?
Yeah, I was seeing it. That looks pretty good.
Yeah. Thanks to this dummy, we can check our motor mount design
And our CG also.
and CG also. Yeah.
Awesome. And you showed your CP and CG on the presentation. That looked all good. I went back and looked at past reports, and they all looked fine too. See, I'm just trying to go off the mental checklist here. Eric, is there anything you wanted to see, Eric, off of this?
What
Can you
type
repeat
of
it
batteries
again?
are you using?
Battery?
Yes.
in avionics, right?
Lithium ion battery we are using.
Yeah, in the picture for the avionics, I did see the 18650s
Yeah.
in their holders. The cylindrical ones.
Do you have any battery that we use? Can you show how? Okay, right now we don't have the battery. Last year we used the battery as well. We didn't have any failure with the battery. There are some risk for lithium ion, lithium ion batteries, but we didn't face any failure. All right.
I mean, it looks really good, guys. I really don't have any the comments on that. You guys hit all the marks in the presentation. So, and if Eric doesn't have anything, I think you guys are probably good to go.
Okay, thank you. Eke, can you show the nose cone? It is pretty good.
Yeah, it's a pretty nice nose cone. You guys made that yourself, right? That looks nice. It's nice.
That is some very high quality carbon fiber.
And the top one is removable.
Nice.
And
oh, nice catch.
This is a part of show.
Yeah.
And we place altimeter into the nose cone. There's a device altimeter too, which the measure the altitude. We can place the device into the nose cone.
And where's your telemetry at again? Where's your antennas at for your GPS?
Again, can you show the avionic bay?
Here.
This is the avionic bay. We will montage our devices onto the this bay.
Okay. And that goes where again in relation to the rocket?
Can you ask again?
And where does that go in relation to the rocket? Where is that? It's in the middle, right?
Yeah. Again, can you show the place of the avionic bay?
Yeah, over there. Okay.
Here we have camera and the
Yeah.
avionic.
Gotcha.
with
Okay.
other of the camera.
Cool. Okay.
And since
Awesome.
we use fiberglass, there is no Faraday cage risk.
Yeah, that's what I was worried about. Yeah. Awesome. Have you guys tested it with well, you don't have that much aluminum up and down. I think you should be fine. You should ignore what I was going to say. Yeah. Cool.
How
Let's
about
see.
our payload?
Yeah, let's look at that.
It's
It's
almost done.
foldable UAV. It has foldable frame. We place it into our rocket by folding it, and after he goes out to the rocket, he will open his arms, and then he will fly. But it will go land until the 100 feet with parachute. After 100, he will land with his own rocket, the own motors and blades.
Do you have estimations on how far the payload will drift under parachute since you're leasing it so high up?
Actually, we have eyeballs here, and then we link the parachute to this eyeball. And this is our cord, which we use Kevlar cord.
I guess Eric asking about the distance between launching site or the rail and the final location of payload, right?
Yes.
Yeah. Actually, we're curious about it, but unfortunately, we have small size of parachute, the drag parachute, so it shouldn't go far away, but it's up to wind direction and the turbulence of the according to altitude and also the wind speed actually.
And wind speed, yeah. If I remember correctly, last year you were on day 1.
Yeah, exactly, day 1.
Yeah.
And I think you were the first volley. So like in the morning. So you probably launched around 9 or 10. The winds are usually lower at that time.
Exactly. It's on purpose, by the way, as you noticed, because the wind is filling our everything actually, the rock trajectory or the recovery stage. So that's why in the early morning we just want to just fly,
And the payload has a GPS tracker on it, correct?
Yeah, for
Okay.
sure.
Okay. Good to hear. Well, I don't have any other questions.
Okay, thank you.
Me neither.
Do you have any questions for us on this project?
Sorry? Yes. Actually, we designed this payload like a CubeSat, but it's actually UAV CubeSat. It's something mixture. Can we get a CubeSat point with this payload?
I don't know the answer to that. That's probably something. It's probably something. So we're the more like technical rocket judges, not necessarily the payload judges. I would ask the Hero X forum, and they'll probably give you a quick answer.
Actually, it's with the dimension of CubeSat. It's 10, 10, 4 dimensions.
Yeah, so CubeSats are generally 10 centimeters by 10 centimeters.
Yeah.
By 10 centimeters, that's 1U. So 3U would be 10 by 10 by 30. From what questions I remember from the HeroX forum, that does not include anything that's attached to it. So like eye bolts, parachutes for that kind of payload don't need to be in that form factor. They can be outside of it. Though your size question may, I think, have been answered. I just can't remember what they answered. Speaking of the payload, what are those black panels made out of?
Would you please?
On the payload?
I guess it's carbon fiber, right, guys?
Yes.
Structure of the payload, the black one.
Glass fiber,
Glass
colored,
fiber.
black colored.
Okay. That's what I was thinking. Do you have any other questions, Christopher?
I do not know.
Okay, I don't either.
This looks pretty good. Cool.
Okay,
That's all we had then. Yeah, hope you guys have you guys have to submit. Well, I saw you're recording it, so make sure to submit that to HeroX in that thing is email. You got to submit it to. But good luck traveling over here, and we'll see you guys in a few weeks.
Hopefully.
Yeah, you will. Cool.
Okay, thanks again for your time and for your participating. Again and again, we are so excited. Hopefully, we will meet with you there, and hopefully, this time we will get first place. That's all for the meeting. Thank you so much.
Sounds good. See you guys.
Yeah.
Bye.
Bye.